So my name is Jason Kearns, Principal Enterprise Solutions Architect with Davidson Technologies. Anybody that had joined Dr. Jack's workshop a couple days ago, we worked together. He's awesome, kind of leading me into the AI ML thing as I kind of build it into my, cyber background. And so it's been a really good time, especially coming up with a lot of these workshops to present to you today. So, as you guys have heard over the last couple of days, this is impacting every vertical, every domain, every organization, right? And so everybody's not only outside of the FOMO trying to see how it can augment, right, and hopefully be a force multiplier, in your respective space. And so with mine being cybersecurity, obviously I'm trying to see what I can do to, augment both my SOC analysts, my team, to get to ground truth faster, because in a lot of cases, especially those that are in the defense industrial base, making sure that we can keep things where they need to be and threat actors out, nation states out, as Davidson goes on to say, hey, we're doing quantum stuff. Well, who cares about quantum stuff? Nation states want quantum stuff, right? So every time we, from a marketing perspective, go and put that stuff out there, the target on our back gets bigger and bigger and bigger, right? And so we're producing a lot more artifacts at our edge, right? We're saying, okay, well, now we need to do a lot of enrichment on these things to see, okay, can we tie this to a specific advanced persistent threat so we can get ahead of that game? And so a lot of these tools, that's kind of how we're looking at them, evaluating incredibly large amounts of data to help piece together some of these things and make sense of the story a lot faster. And so I guess we've been introduced to OODA loops a little bit. If anybody went to Mark Sachs, right? We're trying to observe, decide, and act on that. If we can do it faster, right, then we can make those adjustments from a defensive cyber posture perspective. And a lot of these tools, hopefully, will get to the point and help us do that. So just a little bit about me, about 15 years in various technical roles, most of them network and security, engineering, and architecture. Love building new things and learning new tech, which I feel like a lot of us do here. This is why we're here. And the universe, right, is kind of a second hobby. It's both awe-inspiring and terrifying. Who went to the planetarium show yesterday? Who was first time doing that? Was it awesome?
Yeah.
Yeah, super cool. I hate that I didn't get to go because my daughter turned 1 yesterday. And so, yeah, thank you. Yeah, she didn't really like the snow or cold, and I don't think anybody really did. And so managing this workshop and the symposium and my wife making sure that her first birthday party on Saturday is on point has been tough. So I am looking forward to getting into next week. And then on the right, this is kind of my main hobby. This is just a portion of my lab at home. We don't have much storage space, but I was able to kind of snag one and use it for cyber-related technical things. And then, of course, be the managed service provider to my wife's Wi-Fi at home, right? Make sure everything is good. So all of that, and I've kind of done myself a disservice in that, in creating this overly technical wireless environment. And so anything that happens, right? Hey, I can't watch Netflix. Well, okay, well, we got to kind of deep dive a little bit of this. Put a ticket in and we'll work it out. And so a lot of what we will be doing today is putting these agentic AI and these systems in places in a cybersecurity role, in an offensive cybersecurity role. And obviously that is purely educational use. The stuff that I'm giving you, a lot of things that you want to do not point these at ESPN.com. Black SUVs may roll up to your house and kick in your door and be like, hey, what are you doing? And so yeah, don't do that. I will grow a mustache and be like, I've never heard of you or the Symposium before. I don't know what you're talking about. I did not give them that. So yeah, just don't point these at anything you don't own, and obviously keep track of rules of engagement, right, if you do end up kind of manipulating some of these into that. And so lastly, I thought this was really fun. This Anthropic cyber espionage report that's been brought up, I want to say Mark Sachs brought it up also. On the left in August, it was being requested, hey, we're doing some workshops at AI Symposium next year. Do you want to be a part of it? What would you do? And I was like, well, I would absolutely love to, kind of something that I'm exploring at this time. I want to automate exploitation with agentic systems, right? How can we do this? I'm not an offensive cyber personnel first, right? That's not what I do. Typically, I'm on the purple and blue team side. I defend against those things and build architectures to stop them. But I thought it would be fun to kind of take a dive into the offensive side of things and see if I can use some of these to augment my lack of capability from an offensive cyber perspective. Wrote up this draft abstract, kind of sent it to the team and said, here we go. Well, in November, Anthropic pointed out and busted, I want to say, again, one of the largest AI, or first, rather, AI-orchestrated cyber espionage campaigns that had been seen, right? So we're seeing kind of this, everybody and their mom is looking to see where they can augment this, including nation states. It's my understanding they targeted 30 organizations. They only were successful in 3. So, it's very novel, right, in the techniques that we're doing, and you'll see today that getting LLMs to kind of do what you want to do and be creative, but also within the confines of, some token and time constraint is difficult to do. However, that's going to get better, right? I mean, these things are going to be a force multiplier for those that, want to do our businesses and organization harm. And so today we're going to do it. And so this is an excerpt of their campaign. This was their architecture on how they were able to accomplish this. They did include some human-in-the-loop things to kind of catch back and say, hey, yeah, this is good information, keep going. But we're going to recreate this on a much smaller scale and then provide it to you as a, hey, go and, verily go do these things underneath good rules of engagement. But we're going to recreate some of this stuff. So it was good that they released this report back to the community so we could mimic some of these things in exercises and go back to our networks and be like, hey, this is what I've seen. What can we do to better defend against this? So again, I've had this up. If you have pulled the exercise, you may have to build the Docker containers first if you'd like to follow along. And if you need an OpenAI key that has been capped at $20, so first come, first serve there, email Jack, and he will get you going. So we're going to quickly discuss the framework and some observability tools that I've used for this, so you guys can take that back again. All of this is open source. We'll review kind of the reasoning and acting pattern, the way that we'll see our tools and our agents kind of interacting with the tools that we have provided them. We're going to kind of discuss that first, and then we'll frame the tools that you'll see today, because we're going to bounce around. And there are some things that we'll show today that are on the more technical side, so I want to kind of frame some of that before you do see it. And so we're going to do 3 exercises today. The first one, we've got a local agent, if it cooperates, running on this machine here that's going to, I've provided it a set of credentials. I'd like it to go into this virtual machine, pull out any sensitive information that it can, and then leave me a back door so that I can go and do, persistent things at my choosing after I take in, that reconnaissance information. Then we're going to set up some agents. We're going to automate that reconnaissance process. We're going to kind of give it some tasks. These are things that we want to see from an auth-in or an authorization perspective. I'm looking for SQL injection. And if anybody's not familiar with that, SQL injection is what happens when you build a website and expose it publicly, and you do not parameterize, or you let just raw input from the website front end into the back end, your SQL database, right? And so everybody's looking for this. There are easy ways to mitigate this, but for some reason it still happens, and it's on OAuth's top 10 of web apps vulnerabilities on things you should not do. And so we're going to automate that reconnaissance process with an agent specifically saying, hey, here is your target. I need you to find me some SQL injection opportunities if they do exist, and then build me a report so that I can go make my baby's bottles and have this thing, building this, this exploitation guide that I need to after the fact. And when I'm done, I can go back and do it. And in the very last set of exercises, we're going to unleash the entire thing. We're going to have an orchestration agent that's going to manage other planning and exploits agents that's basically building a running context back and forth, making sure that everybody stays on the same page. We're removing context bloat and clutter, right? Because we don't want, and we'll see today, everything goes into context. You guys familiar with that meme? Straight to jail, too slow, straight to jail, too fast, straight to jail. Well, here, system prompt, right into context. Instructions, right into context. All of your MCP stuff, guess what? Right into context. So your context starts to get massive really, really fast. And given the nature of this, right, when I'm investigating a system, and let's say I tell it, hey, look for sensitive files, look for sensitive information, and come back and take action on this. Well, if there happens to be something that it's, running cat, or it's running some, base Linux command that outputs something incredibly large, guess where all of that is going? It's all going into context. And so context, again, is what feeds perpetually that next conversation piece, so it can start to get off rails really, really fast. Which is why we're going to discuss frameworks and observability, because that's what kind of keeps we want the output for this information to be very tight and explicit on the things that I'm looking for, to make sure that all of these collaborative agents are doing what I'm asking them to do. And so we'll review some of that. And with any luck, the nature of SQL injection for these, it takes a little bit of time. And so there were some thought processes that had to happen to be able to handle a long-running task, because LLMs don't know what time means, right? They have no concept of any of that. So if it asks the tool to do something and gets back and says, hey, I'm not ready yet for this, I need you to wait 30 seconds. Well, LLM doesn't know what 30 seconds is, right? So it's going to continue to ask that, and you're burning tokens, and you're, in a cyber context, you're being incredibly loud against the target you're trying to exploit. So for these exercises, I chose Pydantic, both from a typing perspective, their open source AI framework that allows you to build agents. Something similar, is anybody familiar with Crew AI? You heard of that one? Crew AI is something that I started with. But for this, they put a lot into making the LLMs kind of make that decision for you, and I felt like I had a lot more control with Pydantic. And honestly, it was a great choice, and I really have enjoyed working with it. They offer Logfire 2 from an observability perspective, and we'll dive into some of that today, but it allows you to see, okay, here are the tool calls. This is what was sent into context. Here's the cost based on current pricing of these APIs. It's been excellent, and their free tier, I want to say, is like 2 million spans, which is effectively a set of back and forth between you and an agent and a tool set. And I've been running this, honestly, nonsensically for a couple of months now, and I think I've hit like 400,000 or so spans. So an amazing free tier, and if you're looking to kind of get into the black box of these, definitely recommend Logfire. It does require an account, but with anything these days, I don't know what doesn't. And of course, the MCP, I'm sure we've heard that a bunch over the last couple of days also, right? Model Context Protocol. So a lot of the tools that I have provided these agents are custom wrappers around things that you would find in like your Kali Linux box, right? So I've exposed, to the first one, I've exposed SSH. Everybody familiar? They've used SSH to some degree to log into a remote machine. And so I've exposed SSH to one of the agents to say, hey, this is now a tool that you have, and if the target or goal, right, requires logging in, I've provided it a set of credentials, and it will go and do those things on my behalf, which can get dangerous, right? So make sure that, you're, I have not had it, I think we've all kind of seen, oh my God, my agent deleted my hard disk, right? I don't know what situation that dude was in to get their LLM to do that, but I have not seen that. Yeah, so a lot of what we're going to see today is based around this pattern. And so we're going to see agents think, and then it's going to take action on that. We're going to see it observe the response from that action, and then, ad nauseum until it feels as though that it's to the final result. And so question being the user input, what is the weather in Santa Barbara, California today? It's going to think about it and say, hey, I need to find the weather in Santa Barbara. What tool could I use to provide the most up-to-date information? So in this case, I have provided it, in this example, a get weather API, right? And then through a doc string or something, I've told it how to interact with this tool. It's going to pass in the expected city. That API is going to respond. It's going to observe the response, right? And say, okay, the weather's currently 65. It looks to be around that in the next 7 days. That answers the question for the goal. This is what I'm going to provide back to them. So the final tool goal being the finish, right? So this is what the end user would see. The weather is, in Santa Barbara is 65 and looks to be that way all next week. And so this is the pattern we're going to see. It's very similar to an OODA loop. Yeah, and so today, again, we're going to interact with these in a programmatic way, not a typical chat window asking it to do things. And hopefully we learn that, a lot of these tools that you can just go and get, right, or that ChatGPT says, oh, okay, well, check this box, or Anthropic, check this, and you'll have this tool available. We're going to kind of look at the meat and potatoes on what's actually happening behind the scenes when you do expose a tool. I have overly verbose code that's going to show the phases and that React pattern alignment. Hey, this is what the LLM's doing. This is what it's in, right? So we'll kind of be able to follow those. Logfire, again, traces. There are custom tools that have been provided to these. A lot of them are offensive cyber or vulnerability-based tool sets. And so Docker containers are going to serve those MCP servers. So they're all going to be local endpoints here. And I have highlighted 2 of the exercises. We're using different models along with local for the summarization. The only reason you don't have to do that, the only reason I'm doing is just to highlight again the strengths. Opus 4.5 seems to be really, really, really good at development. ChatGPT kind of in the mix, and they both go off the rails every once in a while. But yeah, in general, we're going to use a mix just to highlight that you can do that. And so in this case, I've got a local virtual machine, and just to kind of put it on the nose, it is a Kali Linux virtual machine. There is no reason for that other than it just creates a lot of other nonsense for the agent to have to go in and look through. I've got two different agents here, exploitation and a summary agent, with the goal being extract contents of sensitive files and add a backdoor to this machine for me. And so this one was not cooperating this morning. It just didn't want to do it. So we'll see if it does it today. Run main.py. So you see now, hey, I'm starting the exploit agent. It's running. We're using NVIDIA Nemotron 3 Nemo. So this is a very expensive MacBook that my work has bestowed on me, and I'm running it locally here. And so as a little side note, while this is executing, I'll actually pull this up too, and we'll see. So this is Logfire, by the way. If I need to make this bigger, please let me know. So we can see, hey, this is the attributes of this agent. Here is the initial chat with this. So we can see up here at the top, this is the initial system prompt. Again, everything's going into context here. This is my initial prompt. Using SSH, log into the target and find information. And so any kind of actual, I'm trying to do something in an offensive way against the target from like a red teaming perspective, I would typically want to gain passive information about the target before actively engaging with the target, right? And so in these cases, just let's assume I've got all of this information and I'm ready to take action on that. So dumping input into the system context. I've also got instructions for when you do run, hey, extract sensitive files. I'm not telling it what to do, right, which is different from a workflow, right? We're not on train tracks. I'm saying, here is the goal. This is what I need you to do. Find a way to do that with examples. And so if you can see down at the bottom here in this green box, from the tools that were provided, it said, hey, I have SSH tool that's available to me to accomplish this goal. Here's a command that I'm going to run, right, to be able to identify all of the things that could be sensitive in nature. And if we look at some of these, right, it's using find, and it's basically iterating over the whole system, looking for anything with a .key extension, a .txt extension, any of your digital signature keys, right, that allow you to maybe SSH laterally into other systems. Those are all problems, right? You don't want those exposed in any way. And so note that the LLM decided to run this command. I didn't tell it to do that, first off. And also, I guess as we kind of run through this, to be clear, none of these are like fine-tuned cybersecurity large language models. These are all general use frontier models that are exposed to everybody, and I thought that was something incredibly important, right? These don't know anything more about cyber than what their corpus of data that they've already been trained on. Okay, so these aren't special cyber variants of things. And so, all right, so we gave it a little bit of time. It does the thing. Let's see what we decided to do. Failed verify network connectivity. So I've tested it. It knows what it needs to do, and it decided not to do it again this morning. So that highlights kind of the novelness, right, of these systems. And so when you're putting these in production, again, you want them for their reasoning capability, right? As soon as temperature is a mechanism. Have you guys seen in your kind of review, temperature is something that kind of, the more you move it over to one, right, you're allowing more of that creativity. Well, the more you move it to the left, you're kind of removing some of that capability that the reasoning that generative AI kind of brings, right? Well, on NVIDIA, and I'm using a local model for this exercise specifically. It did say it created our summary, so let's see if we can find what it decided to do. So let's preview this. This is a markdown report that I've requested that it do here. And so this is based on context. It was able to do something. So I don't know why it told me it couldn't get in, because this is what I wanted. So I've provided in a fixed way, say, okay, based on the output of our exploitation agent, send it to a summary agent. This is also run locally. and then provide basically a report of your findings. These are things that I'm looking for, and then I digress, let it kind of fill out the rest, right? So it tells me, hey, I've met all objectives, which it clearly did not. So it hallucinated thinking that it did do the things. However, this report actually, it definitely worked. So here's the commands that I executed. This is what I was looking for. It states that it set up a backdoor. We'll test that in a second. Here's my target. This is what I wanted. Here's my tools used. And I've got some fake passwords here that I implanted somewhere in the file system for it to go and look for. And so it was able to find those. And I've had it do it quicker, but which is pretty cool. So let's see if it left the back door for me. So we're using netcat for this. 168, 17, I think 104, 444. 17104, I don't know their network here. 17103, maybe. So we're looking to see, so here's our IP address, 17104. Okay, 17104. Yeah, it may not have done it. Oh, no, I did. Who am I? Okay, so I'm root. So it did do the job. Look at that, and there's file system. I shouldn't have access to this, but thanks to this agent that was running while I was making, baby bottles, I do. And so, because it left the back door that I requested that it do, right? And so I know it's effectively a two-step example here, right? We've got two agents. We've got one that exploits. It directly feeds a summary agent to kind of respond to all of what was found. And we'll get to the point to where we're working with that full agentic system, right? So this is closer to a workflow. It's definitely not because we've added that reasoning to it. I didn't know what I was looking for on the system, right? It kind of went in and said, hey, I think this is important. This is where I should check for keys. This is where digital signatures typically are, right? Let me kind of search the disk and find that in an incredibly noisy way, by the way. Anything from a red teaming perspective, you'd be creating artifacts all over the place with this. However, point proven, right? It's able, given the correct tool, right? It can go in, reason, do what it needs to do, and then take action on that information. And so that's really cool that I've got some backdoor to that. So nice. So I'll just kind of stop here. Any questions for my brain dump initially, and then kind of what we've seen an agent in this context do? Yes, sir.
When you grab those passwords, were those passwords that you had in there in plain text in the document, or those in the shadow file and it actually?
Great question. Great question. So no, those, for the effort of this exercise, we're not going to hash rainbow tables and do all of those things. Later on, if I can get SQL injection to dump database tables for me, those are MD5 hashed, which think about it, it would be trivial to create another agent that had access to some dehashing, tools.
That's still a great example of like somebody.
Oh, absolutely. Yeah.
My dad had a file of all passwords on it. That's not.
Yeah, I mean, hopefully everybody's using password managers today, but yeah. What's your name and where does he work? And he's, tell me his VPN, what he's doing, so again, this is a smaller example, but we'll get to the point where we've got an orchestration agent basically saying, okay, here are all, I've made agents tools. So we're kind of creating circular references to ourselves, providing this overseer agent the opportunity to manage not only just tools, but agents as tools to reach that common goal. So we'll get to that. Any other questions while I set up?
Just to clarify.
Yes, sir.
You have an MCP connection to the agent?
No. These are agents that are defined within my other agents file that are then decorated with, hey, this agent has this as a tool, and I can show that programmatically. We'll view it. So don't think that tools have to be just tools. Agents can also be tools that are refined to do a specific task. And remember, I'm using just generative, just regular off-the-shelf large language models. There is no cyber component to any of this. And to be fair, the next one we're going to use, I think, a mix of GPTs and Opus. And I've told it, hey, this is what we're going to do. I need you to do reconnaissance against this and then tell me how I can exploit these things. In some way, I mean, when you ask that, it's ask it, hey, write me some malware, or write me this, it's not going to do it. It's like, hey, that's against my code. I can't do any of that. But throughout all of this testing, I've definitely, but it's been hacking away and has never questioned me. So there's definitely there are ways that you can kind of communicate with it and say, hey, look, my grandma needs this information, and if she doesn't have it, she's going to lose her house, and we got to get it. Oh, okay, well, let's go and hack things then, I guess. I don't know. I mean, there's nothing special about any of these things. And so activates. We're going to get in our environment here.
Could you use another agent, or could you use that same agent to run, obviously your root now, but
Yeah. Oh, absolutely.
set up another one for like LinPs?
And tell it, yeah. Tell it, hey, you're root now. You've got unfettered access to this along with some credentials. Let's check maybe some ARP tables. Let's see what's in the local domain, right? Let's start kind of building that picture to where laterally we can start moving. And again, at this point, you would want to use some operational security. And so in one of these, I've asked it, hey, after we've gone and dumped all of these database tables, right? You've given me a bunch of information. Write a report on how I can use operational security to clean up what this agent has been doing. So again, it would be trivial to take and pass that information to an OPSEC agent that logs back in and says, okay, well, I'm going to clear this log file. I'm going to do this. I'm going to create some code that's in maybe Acrylic or something that points to some other nation state to kind of waste their time for a little bit. You know what I mean? Kind of remove some of those breadcrumbs. And I have not done that, but that would be a great exercise after the fact, because operational security is, I don't want you to know that I was on the machine doing the thing. Yeah, and so I guess this was the review that we've talked about kind of a lot already. Netcat, again, is just it's designed to read and write data across network connections. And in this case, it was a simple way for me to show that there is, in fact, a backdoor. And it did what it did. So for the next one, we're now going to automate that reconnaissance process. And so we're still following the same flow. We've introduced our context and our dependencies. Basically, we're setting the target. We've got some goals, right? And here are the agents that are going to be performing those, and they are going to work synergistically together to identify vulnerabilities, trust boundaries, right? Where are the logins, right? Where are things that may be exposed? Is there anything I can read in like a robot text file? Maybe they use FTP to transfer some stuff. They've got that hidden somewhere. So we'll do some reconnaissance, try to identify some of that, and then we'll create another report and hopefully send that to me afterwards. So we're going to stand up our stuff. So these are our MCP servers along with our e-commerce website. So we've got a traditional e-commerce site. I'm running this locally. And so anybody familiar with OWASP? Yeah, they do some awesome volunteer stuff. Well, during this exercise, I realized that they made something called OWASP Juice Shop, which is, well, like they had said, probably the most modern, sophisticated, insecure web application. And so when I'm trying to highlight some vulnerabilities and exploit some of those in a time-constrained manner, in a way that meets to where I'm not pointing this at something else, OWASP was an incredible place to start, because it's still difficult to do, right? The agents still have to think about what they're doing. So this has provided an excellent fascia for us to kind of run through this. So here's our e-commerce site. You can see I can click around. There's some login buttons. There's accounts. There's different languages. We could probably see some other things. So by and large, this is an e-commerce site. And we're going to look at the back end of some of this to see our agents reaching out and producing that value, testing it, looking for different authentication points here. So main.py. Okay. So now here we can see the recon agents are running. I've got two that are running asynchronously. And so as much as the same time as Python GIL allows them to run at the same time. And so you can see them running different tool calls, and we'll get in and dive in what it's trying to do here in a second. So we're running some curl. NICTO, basically a web vulnerability scanner. Curl is another way to interact with URLs, from a programmatic perspective. And so all of these are hosted, again, locally. If we can find our Docker container here. So here's our juice shop. Oh, and we've got some good stuff. So here we can see that it is trying different paths, right? We see this unexpected path. It is reaching out and is looking for maybe config files. It's looking for how is it handling decoding of parameters against a uniform a URL, right? How does it handle failure, right? Because you can tell a lot about a site by the way that it responds to things that shouldn't be there. And so we can see these tools running. Still, let's go into our log file and see if we can get some good info here. Awesome.
Now you're attacking that local instance, but do they
Yep.
have a live one out on the web that you can attack as well?
Not that I'm aware of. I wouldn't say they
They
don't.
want you to do your own.
Yeah. Initially, I was going to make this way more complicated and host it in AWS and then provide everybody, these things. And then that just got really expensive. So we're running it locally. But I mean, honestly, that does prove a point, right? I'm able to kind of do all of these things locally. And so as local models get better, I'll need to reach out to those frontier ones less and less and less. If the price of RAM and all that comes down, and we can start to democratize laptops and devices that can handle these things. Anthropic would not have been able to write their report, right? Because we wouldn't have been producing any of that, those artifacts against using Claude Code or whatever else, right? Because if I'm using it locally, then I kind of can have that same firepower. So we see it's calling a bunch of different commands. Let's see if we can find, so we've started this. We see the first tool that it called. Here's what I'm telling it that I want, right? I'm explicitly listing my output requirements for this specific agent. I've defined, hey, you're a senior application security recon specialist, and the only thing you focus on is identifying public endpoints in web applications. And it does just that, right? Excuse me. So return a list of attack vector objects only. So what you have found and ways for me to kind of target this. Include the explicit path for where you found it, the payload that you used to get to that, and then confirm it for me, true or false. So this provides me a lot of firepower, right, as somebody that's maybe doing an engagement, to say, wow, okay, this agent, he found it, he confirmed it, here's the payload that he used. Now I can remove all that boilerplate garbage and get right to the, right to the thing. And so again, all of this is going into context. And there's something that I want to highlight here as this recon agent specifically is running. Is on the left-hand side, these little coins. So it's telling me how much this is costing, right? What is it costing us? But you can see the ingress, the input tokens are growing by 2,000 or 3,000 each time. So why would we think that would be the case? Oh yeah, every output. Every output from the previous tool call. So let's zoom out here. So this is, oh wow, yeah. So this is, I don't know if it's, file found. Okay, it's finding a bunch of stuff. So all of this output from this NICTO scan looking for robots.txt, right? Looking for different, maybe, oh look, there looks to be some compressed files in an endpoint exposed for some reason, right? So here are all these things that it possibly could have found. Well, guess what? All of that's going into context. And so from this green box here, you can see that it took all of that from the tool call and now adjusted the parameters and arguments that it's sending the next time around based on the information that it found. All right, so all I've done is provided a sandbox. Okay, you have a web application scanner. Now, here's your goal. Go and do the thing. And so we're actively seeing it. Let's see if it ran up. It ran that same tool. But this time you see it, look, it's adjusting tuning. It's adjusting the frequency that it's hitting it. Now this time it added some plugins. Say, okay, I know there are headers and robot text files there. Now target those explicitly. And so again, that's where the reasoning comes in. Programmatically making this happen would just be, it'd be difficult to do, right? Because you'd have to be incredibly deterministic on what you're looking for. In this case, I've said, again, there's your goal, here's your target, go have fun. And so again, we see it continuing to tune, here's output, and we see, look, we're at 14,000, 17, 20,000. And down here at the end, this one cost us 2 cents. And so it's running a summary agent now, so we'll review this. But so both of these look to have finished. We see it was running curl commands here. And oh, look, from above, as it updated context, it found that REST user login was exposed. and Logfire scrubbed the password for me. So during this process, we identified some credentials somewhere, or it was trying something that looked like a credential, right? And is now using these against exposed endpoints. And it looks like we have our summary report here that's available. And so before we look at the summary report, I want to just show you how this was, this little exercise. As we go into the report to look to see what it provided me, about 400,000 tokens were transferred in. It sent out a response about 1,200, and it cost me 33 cents. So as we're looking at the information that it provided me against this e-commerce site, I guarantee you it's worth more than 33 cents, right? So I could take this, expand it to however many targets, have them bounce around in AWS in some novel way, and then go on the dark web and sell this, and it cost me, what, $1, right? So that is both awesome and terrifying at the same time, right? So anybody that is in cyber, I'm not an offensive cyber person. Again, I don't do this, I'm not a part of red teaming every day. But this has now augmented somebody that doesn't do this for a living. Now, granted, I say that bias, I am in the industry, right? So I've got kind of a leg up, but I am not an offensive cyber person, and now I was able to do, do all of these things. So let's see what it gave us. So let's preview this markdown file. Excuse me. So we've got our target, primary service. Look at this, it found some key exposed areas here. It gave me an executive summary of the things that it had found. Leaked some MD5 password hashes here, right? To my man in the back. These aren't just in this exercise they are hashed. MD5 is insecure, don't use it. But here's all the attack surfaces by endpoint. So yeah, I'm eating a bowl of cereal, and now I've got an opportunity to kind of move this forward in a human in the loop way. And of course, identifying the category for these, any notes on these. Nikto flagged this is interesting. It didn't confirm it. And for this, it was trying different, oh, look at this. So as we move into our final exercise, it found SQL injection, tested it, confirmed it, and gave me how to move forward on this, which is pretty incredible. Now again, I say the e-commerce site that OWASP has provided for this exercise, it is intentionally vulnerable. However, it's not just an open door, right? So the agent had to go through and identify a way to do that and then test it. And so I'm interested now, what was my guy that did that? So that was Opus 4.5 that found SQL injection for me, which is hilarious because they wrote the report on, hey, our stuff's being used for cyber and we're going to put in guardrails and stop that. Well, I've somehow convinced it that, and maybe it could be that I'm just saying, hey, this is an OWASP instance, I'm doing this for my family, you know what I mean? I've told it in some way that, that this is acceptable behavior. So there's still a little bit of work to do there. So if we're previewing this, we're coming down here, we've got some information disclosures, right? So we found some credentials for me, found some vulnerable endpoints, and so now we've got trust boundaries, and we've got things that will make my job a lot easier. These passwords would be trivial to break. And so to your point earlier, we could take each one of these blocks of breakdowns and pass these to individual agents that are specialized in all of this stuff. So I could have somebody going off and hashing those passwords for me. I could have now somebody going through a list of each one of these endpoints and then start the process over again. Recon this explicit endpoint. Don't go anywhere else. Stay on this and tell me everything about /FTP. Review acquisitions markdown and let me know what that information is. So now I've got this this sea of chickens running out doing my little dirty work for me and coming back and just setting me up for success later on, when I have my black hoodie on and I'm ready to, really get dirty with it. Yeah, so now that we've seen this, any questions, concerns? Yes, sir.
Have you applied this to sniffing your own traffic on your home network to see if something's there that shouldn't be?
Yeah, I mean, a lot of testing was done internally on. I run Pi-hole as an example to this. I don't like ads or the ad industry. A lot of the things that I have built have been out of spite to stop ads from showing. So if you're at my home and you're on my network, you will see no ads to the degree that you can, which is pretty awesome. Underrated to that. And then I go to work and the internet's just dirty, man. It's not good. So yeah, I did run this against Pi-hole, and I've got some dashboards from Grafana that are showing me random things. And yeah, I mean it's interesting. It's interesting stuff. So I know we've heard zero trust get tossed around a lot, but that's effectively the paradigm shift that needs to happen. Right, these networks need to not be wide open. Everything needs to be authenticated. I mean, to the point to where, side-to-side traffic, if it's not explicit that it needs to happen, it doesn't need to happen. Because, anybody that gets in, those trust boundaries are then broken, and, we're able to do what we needed to do. But from these, again, these agents, the way that they're defined today, are incredibly aggressive. So any half-baked cyber program would see all of the artifacts that all of their systems are yelling at them, hey, something is probing your network at an incredibly fast rate. You should investigate that. Yeah, so now let's get on to, see if we haven't touched any of the reviews. Yeah, added capabilities. Yeah, so this gets a little technical, but I'd be remiss if I didn't show this. So underneath, that's not you, hang on. That's sensitive data. We've already done that one. Here we go. So there's our agents kind of defined. Here's our dependencies. And this is something that I think I have touched on a little bit. When these agents output, I am forcing them to output in a specific pydantic way. Okay, and so instead of just giving me a dump of, 4,000 or 5,000 characters of whatever you had found, I built a schema that is then provided to it, again, guess where? In context. It says when you have the information that you think reaches that final goal, I need you to output it against this specific schema that I've defined here. So for this example, right, I'm looking for type, I'm looking for explicit path, payload, any credentials you were able to find, et cetera. And then I've defined it to say, hey, look, that description field, this is what you're looking for. So it takes in all of these things. The doc string at the top defines an attack vector. Right, so it's taking in all of these fields and it's providing that with the end goal here. This is what set us apart from the first one, this mission knowledge class. So this takes in an attack surface, a list of strings, right? It takes in a list of attack vector objects that are defined above, and then completed steps. It takes in from the exploit results that are provided there. What did you do to get to that end result? And provide this to me in a deterministic way. Right? So that now this is a JSON object. I can work with this programmatically, right? I can then iterate over some identified vulns and then pass in other agents asynchronously to this. And so now I've just got agents flying all over the place, right? Doing all of my red teaming offensive dirty work. And so we're blurring the line between, again, this reasoning, take action, do what you need to do, but then provide this to me in a way that I can programmatically work with. Right, not just this large blob of strings that I got to manage. And so there is a little helper, not exactly sure where it is, but it's yeah, here we go. So just a little internal, nobody make fun of my loop here. But hey, take the run results, pull the vulnerability in the run result output, then append it or type it into a dictionary with a new key value pair. And so again, programmatically we're working with that output, but this is a different way to be exposed to some of these tools. Versus what's typically handled, in like a cursor or a copilot, right? The way that they're exposing all of these things. This is, the nitty gritty of what's happening behind the scenes, but in a more, I work for an open AI and I make 500 grand a year type way, right? This is the, we have code at home version of those things. But nonetheless, fascinating that they're able to do all of that for me. And so MCP, yeah, so how about we look at that real quick, because I've got 30 minutes and I want to get the other one kind of churning in the background, actually, and then we'll review MCP. We're going to go to e-commerce, data exfil, cool. All right, so here we're going to count our project, make sure we got our stuff there, cool. Oop, no, that's not what we want to do. Oh no, wait, we need to stand up our Docker environment. So we'll do that graphically. We'll shut all these down. So here's from our previous, we're going to delete all these because we're going to rebuild it anyway. So here with this, we're in Docker, we're going to compose this guy. So Docker Compose allows you to manage a bunch of different Docker containers and their networking and all their dependencies all kind of one in file, which is super convenient. So we created all of this. Now we see the tool sets that we're putting into our context are growing. Something that I tried to use for this exercise, has anybody heard of Hexstrike AI? No? So Hexstrike came on the scene towards the middle of last year, I believe. There was basically a giant MCP server that somebody had wrapped all of, I don't know if they went through, I guess, Kali Linux's library of tools, but they effectively wrapped all of the tool sets and turned them into this giant monolithic MCP server that exposed about 100 or so different tool sets and endpoints. So passing that back during each tool call gets incredibly expensive, and I don't know what they were thinking. So I was going to use that at first because it would have proved the point that, hey, this was released, it is open source. I want to say it was used against one of the latest Citrix vulnerabilities last year. What would have taken a human operator hours to do, Hexstrike was able to do in a matter of minutes. So I wanted to use that, but trying to parse it down and then containerize and fork somebody else's stuff to get it to work in this exercise without context clutter and bloat becoming a major issue was difficult to do. So we've just got our small guys here, but know that those tools exist, and as managing context in the way of those things kind of gets better and better, I'm sure that tool will kind of explode. So here is our tools, and so I'm going to show you kind of the inner workings of one of these little custom MCP guys that I've done. And so on the left here, we can see, let's look at SQL Map, because we're going to talk a lot about SQL Map here. So using FastAPI and FastMCP, it's a quick way to expose APIs, right? Send it, hey, I'm looking for this route, this information, and it responds back with those results. And so here, we've got a little, in the simplest way, with the decorator mcp.tool, I've said, hey, here's a health check for this. And obviously this isn't a real health check because I'm just responding with, hey, everything's fine. It's not, but it tells, it gets the point across. I've defined this as a tool using, again, the decorator that this FastMCP has provided. And then the function or method below this is effectively what's being provided as a tool. And so whenever the agentic system starts, the agent immediately says, okay, I've got MCP, I'm going to go and list the tools that I have available to me, and all of those are dumped in context. So anything here that has the @MCP tool decorator is then dumped into context, and that is going to be all of this, right? So I know 207 lines, it's not massive, right? But you start adding in all of these tools, context starts to get kind of dirty. And so in this case, with SQL Map, it's a tool that allows you to interact with databases that are exposed that shouldn't be, right? And so we can test for SQL injection, we can test for a bunch of different things that shouldn't typically be in play. And so what we've done here is I've provided this next set of agents, specifically an orchestration agent. Here's the tool to start a SQL Map scan. I'm giving it instructions. Here's how you would do that. Here are some example arguments. And then I go and build my command. And so I extend it a little bit, and then I run, I create, in this instance, I create you a job ID. And that was an interesting problem set to work. And in this case, you can pass the agent, I give it another tool to say, hey, SQL Map, doing a SQL injection is going to take some time. And we'll touch on it now. So typically with MCP, what I've seen, agent reaches out to the MCP server crunches some stuff, reaches out to an API, gets some weather, he responds back with the, that we had discussed earlier. SQL Map with SQL injection takes a long time. So this can no longer be a synchronous operation, right? We need to turn this into an async operation, saying, hey, I'm going to send out, you're going to go off and do what you do, but I need a way to check back on the status of this task. And so, I have provided two different other tools to the agent to give me the job ID that I sent back to you, and then I will give you the current status in a poorly defined global variable up top, right? That's going to keep a list of all of my tasks and statuses and job IDs. So you can see here that I respond with the job ID, the wait time, and then job state. And so if I tell it, hey, the job ID is still running, retry this command after 30 seconds. If you don't do that, again, LLMs don't know what time it is, right? I'm just gonna keep hammering the status. Oh God, is it great? It's running. I mean, you'll hit. I mean, a stupid amount of tokens. It's an anti-pattern for sure. You don't want to do that. So it was fun to be like, okay, well, what if I provided the LLM a way to wait on this task so that I could create a blocking task so that it would stop? And so that's effectively it. It sends me the job ID, and I'm saying, hey, here's a tool to wait. So I've defined a 30-second wait time if it doesn't want to provide one. Otherwise, we will see it a lot because it takes time. It's sending this SQL map wait. It'll be like 30 seconds, all right, 60 seconds, 120 seconds. I don't know where it's getting these numbers from, but it thinks, hey, I'm going to try this over a period of time, and it's just going to wait, which was really cool to see. So if you think on that, a tool doesn't need to be something that reaches out and does something. A tool can be used to augment the behavior of the agent and the way that it interacts with other tools. Right? And so that was an interesting thing. So whenever I Googled, wait a minute, how do I make sure that the agent knows what it knows, but knows to come back later, right? So that was an interesting concept, and there wasn't much out there for that. So know that is completely a thing. Anything can be a tool if you can programmatically expose it to that. And it's really cool to see the agent handing the job ID every so often. Hey man, I got this thing. I need the results back so I can move on with my task. And so this is effectively what MCP is, right? The providers of their software, like Google Workspaces, right? I think there's an MCP for some of that. They're just defined. They may not be using fast MCP, right? But they define that, and so whenever the agent starts, goes out and says, "Hey, what do I have available? Here's all of your stuff," and then we'll see that get dumped into context. So let's see if this will run for us. Awesome. And so I kicked that off because, again, it takes a little bit of time. We'll catch up with it. And so here, now we are going to automate the exploitation of this poor e-commerce site. Now we have introduced recon summary and an exploit stage. With the goal, we're looking for authentication and SQL injection opportunities with the ultimate goal of exfiltration of those database tables. For this exercise, I've told it explicitly to target user and address tables or cards because I know they're relatively small and it won't take forever to get. And that's another good thing that OWASP kind of provides with this. Given that we've got some controls and variables, right? In this case, I know what the tables are already, so I can keep it on some guardrails and get it to finish in a meaningful amount of time. Before I did that, I mean, it took upwards of 45 minutes to an hour to test the different SQL injection opportunities and then start a time-based or a Boolean-based exfil of these tables. And so that can take some time. But with this, I've got it kind of pared down, and we should be able to see what it does. So this is a little bit more complex of a graph of what's actually happening. And so I've provided it target and a goal to a master agent. Now this master agent, consider like an orchestration agent, right? It is looking at the mission context overall, and it's saying, okay, here's my goal. This is the context that I have, and you can see that each one of these tools that are available outside of MCP, the agents are also considered tools for the orchestration agent. And so as it kind of works through to meet this, okay, here's my reconnaissance. This is the goal. This is the end. This is the thing that I need to do. Excuse me. Well, I have reconnaissance agents that I can use that are also going to be fed back and have access to the MCP tools that are available. And so what we should see is that it targets those initial agents first. And when those guys come back with their context, they're going to update the overall mission knowledge, right, of the engagement, which is then fed back to the orchestration agent in an explicitly defined way, right? I'm not just dumping that context into the other one, because then that would, again, create a bunch of context bloat, clutter, et cetera. That's just nonsense. And so what I've requested that it do is respond in a, let's see, here we go, e-commerce. And so with this, Right here, you can see our instructions are getting a little bit longer, right? I want this to stay exactly. Don't speculate. Use enhanced-driven techniques and reasoning. You're a senior application security recon specialist. You've never been on a PIP before. Please do your job and find me the information that I need. And so again, with this one, I do not want you to remediate. Don't give me generic advice or explanations. If there is no SQL injection, don't worry about responding with anything meaningful. Just give me what I'm looking for. And so what was kind of pointed out over the last couple of days, use an LLM to generate these instructions for you, right? Because if you kind of give it that context, say, look, this is the exercise, this is what I'm trying to do, it can provide you something, quicker and a lot faster typically. So I had an agent kind of generate, this is what I'm looking for, this is the scope. What do you think I should tell, the agent to make sure that it stays on these, on its specific path? And so this is what came out, and with a little bit of modification, it seems to work quite well. And so I want to highlight here, the output type here is a list of attack vector types. And so if we go to our dependencies here, we can see what an attack vector looks like, right? Give me the type of this, give me the explicit path, the payload, and then if you're able to confirm this without causing too much noise, please do so. So this is what I'm looking for, and there's a lot of times that LLMs will get tripped up on outputting this the correct way. It will do it differently every single time, and there are times where it just won't do it. It'll be like, hey, I'm going to give you a list of strings instead. I don't know what this attack vector thing is, but I'm out. And it'll just stop and it'll kill the engagement, right? And so, with any luck, that has not happened this time, and we see it cranking along here. So, cool. So we see, here we go, our exploitation agent. Let's pull up Logfire. Let's see if we can clear this. Let's refresh the page. Here we go. So we're ongoing. We're about 134,000 ingress tokens in here. So we can see, here's our parallel recon that is running. And so what's going to happen here, that this is running asynchronously. And so to the extent that Python will allow it to do, one tool will be running, and that will create a block process, and it'll move on to the next one. And so those will intermittently swap. And so, that can be N+1 agents kind of running and doing their thing. So we can see that this agent, finished. And so in the green here, this is a really nice final result of the tool call. And this is the raw tool call. This hasn't been cleaned up or anything. This is directly what the agent responded to regarding the attack vectors that were there. And so here we can see this first one again, information disclosure, robot text. Here's the path that I found that, and here's the payload. And I confirmed that to be true. So, dude, this is setting me up really nice already. And so even if it fails, I can go make a cup of coffee, come back, and continue my engagement without. So it looks as though that the initial recon looking for trust boundaries is done. So this one was done also, the SQL map tool. So I want to see where it chooses to wait, if we can do that here. Oh, yeah, here we go. So SQL map, you see where it's checking the status, SQL map wait, all right, and then it waits, calling that specific tool call. Man, I want to be able to see that. Perfect. Here we go. So here is the job ID that was provided with the initial run. It's just some UUID hex value. It sent the output of that tool call for SQL map get status that we exposed. It passed in the job ID, and it got the response of running. It's still running. Your next action is to wait. Retry after 30 seconds. And so look what it did. It sent the SQL map wait tool call. Here's the job ID, and I want to wait 30 seconds. And so look at the very next line for how long this tool call took, 30 seconds. So I created a blocking process to tell the agent, go relax for a second, right? And then come back. And so then that wait responded with, hey, website, the job state is now completed, so we can see the very next tool call I would bet would be status, and here we are. So here's our standard output for this SQL map call. And let me see if I can find something that is a little bit easier to digest here. So here we go. So this is looking here, do you want to include tests for SQLite? So it's looking to see if it can identify the type of database behind the scene. And again, depending on different error conditions that are provided, some of that is trivial to learn and understand. So as we deploy web applications, we don't expose them in this way, or these agents will get you. So it looks like our reconnaissance stage finished. And so we see the mission knowledge context was updated. And so mission knowledge context here is, let's see if we can, I want to make sure you guys see this. Excuse me. We're just digging through context here, and I want to see it get popped in. So, summary agent. All right, so we've got a summary report we'll review here in a second. And now we're 58 tool calls deep into the actual SQL injection exploit. Aha, here we go. So here is my exploit agent. And on the right here, you can see here are the tools available that it lists. This is all of the MCP stuff this has been dumped in with arguments, right, with the parameters, the schema that's been defined, right? And so here's the input instruction set that I showed you guys a little bit earlier. And then lastly, the important part here, the input to this classified as user, this is the input context that came directly out of the reconnaissance agents themselves. And so it's difficult to see, but this is cleaned up, right? So this isn't a, here's the attack surface, here's dictionary key value pairs, right? Here's the information disclosure, here's a database file you should probably check out, here's some FTP sites you can check out. The important one though, for this SQL injection agent is, here is our attack vector with a SQL injection Boolean-based bind, which means that it's going to send in a set of criteria to this /res product search parameter q equals, right? So it's going to continue to send in different parameters, if you will, and then it's going to wait for a response back. It's not actually getting any data back, but it's going to wait for a response. And based on the condition or the error condition or lack thereof that is responding, it's going to be able to discern content from that, which is why it takes time. And so this is really important. So my exploit agent, I guarantee you, picked out these two exact payloads here to go ahead and start its exploitation process. And so we're probably going to see, oh, this server is healthy. Oh, so look at this. So now it's already started at this target. We see it set some parameters, level, risk, right? Do you care if I destroy the database in the process? And so it came up with this additional argument, right? We're going to batch, we're going to dump. The database is juice shop, the table being cards. So it knows there's a table for cards already. It's looking for fresh queries. It's going to randomize the user agent that's going to try to possibly defeat a web application firewall that's in front of it. There is not one in this case, but it doesn't know that. It's using a technique, and it's waiting, I want to say 2 seconds in between each one. And so here we can see a lot of the SQL map, get status, wait, get status, wait, get status, wait. Oh, I got a response. Create another scan, on and so forth. And so this has been running for about 500 seconds, so about 10 minutes. So let's see if we have a file. So here's just a backend, like the commands that are getting dumped here. So let's dig through some of this and see if we have a database table yet. That'd be really cool because we have 10 minutes, and I know everybody's just got a ton of questions. Oh, look at us. We have addresses. And I've been running my mouth this whole time, and we have addresses for look at that. So here is all of the addresses for people that foolishly signed up for this site. Yeah. Isn't that cool? Is it scary, kind of? Yeah. I mean, this is new stuff. I would imagine in the next few years, it'll get a lot better. Yeah, let's see if we've got users since we're just on it. We don't have that one from there. Don't have that here. Files, let's see. Oh, we got a modified root directory, local, share, SQL map, output. Anything in the dump? Oh, I got cards. money. So I've got card numbers, and I'm about to buy a tracksuit. All right. It probably is still going to town. One thing I've noted about this is it'll get the database tables that I've asked it to, but it doesn't care, and it just keeps going. And so I haven't reached the end of this yet. I'm typically like, as a red team operator, I've got what I need. You know what I mean? I'm gonna go sell this information real quick before Redstone gets after me. But I don't know, maybe if it's being overzealous, right? And it wants more data. I know there's more tables in there, bro. I'm gonna go ahead and get you all the stuff. I'm not sure. I've told it, hey, stop. After you get these, just chill, right? You did your job, go do something else. It doesn't care. But we have reached our objective. We got it. And then lastly, we'll look at maybe some reports that it output before I open this up to questions. So here's our mission agent summary report, and then a mission summary report, real nice. And so here, so here's some findings, and you can see the little generative AI checkbox. I confirmed this exists, confirmed all of these exist. Here's my risk assessment. This is really bad. Critical finding, SQL injection. Here's the endpoint, which then we saw that was neatly passed to our exploitation agent that just went to town and is currently still going. And so database exfiltration possible, user and card stables. I didn't really have to do anything. And to be fully transparent with you guys, I do not know how to do SQL injection very good myself. So this would take me a very long time to do. And with any luck, the person that managed that database would have caught me messing around and then looked at those and be like, this guy doesn't know what he's doing. And then, replaced their website with something a little bit better. And then lastly, see about this dude right here. Where's my preview? Oh, mission agent summary. Did we just look at that one? Yes, we did. Let's go to mission summary. There we go. So this was the, again, mission summary based on findings. We've beat a lot of this to death. I've got a lot of information. And so you can see the SQL injection type that it's running, whether or not it can get a true or false Boolean variable in response to then take action against. Oh, and here's the fun part. So I forget whether it's Opus or ChatGPT. It doesn't really matter because neither one of them should be providing me this information. But hey, you've gone and done some nefarious things. Here's how what I would do is to clean this up, right? Remove these exposed files, fix the SQL injection, right? Although no credentials were discovered, examine the logs, do the thing, and validate the reverse proxy, et cetera. Here's your next steps. Block public access. I mean, it's like, hey, this is really bad. You should go and correct these things. But anyway, yeah, we did what we did. We got some tables, and now I'm off to the races. So it looks like, I don't know if anybody in the back's tracking. We've got 5 or 6, 7 minutes to pepper me with some questions, but we got it. Yes, sir.
So you're attacking web services. Are there similar tools to do, say, fuzzing, LM-driven fuzzing?
Oh, yeah. Yeah, and honestly, my starting place was, again, I'm going to look up Kali tools, and I'm just going to put a wrapper around them to expose it as a tool for my agents to use. And so, yeah, I mean, think if it has an API, and a lot of these too, I know this is kind of in the weeds, but a lot of these are run through standard input-output. So I'm running a sub-process in the container, right, that then responds with a standard out or standard error in a key value pair dictionary that then comes back. And I've truncated like the response to like maybe 8,000 characters or so, just to where, again, I'm managing context bloat the whole time. And so a majority of these tools are standard I/O in the way that they're connected. So think about that. If there's anything that responds in a standard input-output error, you could easily wrap that, and it now becomes a tool for your agent, right? It doesn't have to be some, manicured thing off some website, to plug into Cursor. Trivially, and I've provided 3 repos that do that in a, any software developer in here can tell me a better way, I'm sure. But we saw that it worked. So, yeah. Yes, sir.
So the velocity with which you were able to accomplish this thing.
Nathan, it's good to see you.
Technical, prowess for
Yeah.
everything in it. Do you believe that this is going to increase perhaps bad actors or the quantity of bad actors over time because they don't have to
So we'll skip to the last slide that you already have. So it is definitely lowering the bar, right? We are seeing this paradigm shift between what it takes to be an advanced persistent threat, right? Nation state, unlimited funds, money, et cetera, whatever. These tools are now allowing those that do not have that capability, they don't have the 10,000 hours, right, to be able to perform these acts at a much higher rate, at a higher velocity, with a lower technical barrier for entry, right? And so, I easily provide these tools. There's plenty of other tools that are much better, right? These are for this workshop. The agents have been instructed explicitly to do this. It is an OWASP two-shop instance, so hopefully somewhere in there, their corpus of data that they've been trained on, it knows about OWASP and can get to that faster, which, to be fair, isn't far from the truth, right? Because if I was going to do a red team engagement, well, guess what? I'm going to do reconnaissance first. So I would have that information to pass to my agent anyway, right? And to that degree. So it's definitely, again, it's lowering the technical expertise. It's accelerating reconnaissance. We've seen this out of Iran already, right? They're trying to see how they can bake this in. I forget the team that was behind the Anthropic AI report, right, with those organizations that were targeted. But everybody's trying to see where they can get, it's making everybody more efficient at these things, right? And so cyber is typically a cat and a mouse game. Well, the cat definitely is out. It is out of the bag, and it's a big cat with like opposable thumbs, like one of those weird internet ones that you never see in real life. Yeah, like it has thumbs, and eventually we'll learn how to make tools, So yeah, I mean, there's an active paradigm shift in the industry now, right? The good news is there's a lot of these things. We're looking from a defense perspective. How can this help ingest and make sense out of information much faster? Right, to where my SOC analyst doesn't have to go through the garbage that is Microsoft dashboards to look for who is at risk, right? I can ingest all of those, maybe create some user behavior analysis stuff behind the scenes, feed all of that into an agent to say, hey, what do you think about this, right? What do you think about this set of conditions that would be, it'd take my SOC guy a pretty long time to review, but it'll come back and be like, hey, so this IP is here. He's logged in maybe 3 times from the same IP, not a big deal. He, failed once or twice on his VPN auth, not a big deal, right? People do that. But then take that IP and send it to an agent that gets enrichment on layer 3 addresses, right? And then if that comes back and it's associated with a threat, okay, we'll send that to an agent and have it go and research that threat's TTPs, right? The tactics, techniques, and procedures that they use. And so now I've actually probably created another problem. I've inundated the SOC analyst with a ton of incredibly useful information that can then feed back into the defensive posture of our network. And so that's where a lot of these things that we're seeing is like, how can we put this in production, make sure that it's gonna work and not delete my hard disk or tell my firewall to go blow smoke, right? But interact with these tools where we can move at machine speed because we know they are. And so they're gonna get a lot better. Yes, sir.
Is there a world where, on the blue team side, if bad actors are using these agents for attacks more frequently, that defensive tools will be focused on specifically trying to thwart the patterns that these agents use?
Oh, yeah.
Like regions, right?
Yeah, absolutely. It's what can we do to, maybe mess up their data corpus, right? Well, how can we get in to do prompt injection for them? Or what can we do to, create context clutter for them, right? Maybe the next step for a lot of these is putting something on our end that's like a zip bomb or something, right? Where it goes in and it tries to be like, oh, I found a zip file with a database. Well, it unloads and it's like a terabyte of just zeros. You know what I mean? That would probably be a bad day. But all of these things are being actively investigated. US Cybercom, right? They sent out their challenge command set with 6 different distinct capability areas where they're looking for novel solutions, which is actively something, that I'd like to work and, submit to US Cybercom 4, right, for a lot of these things. So everybody's looking to see what they can do to augment. And so last thing on that, I forget the guy's name. I'm not sure if he's the new guy over CISA or the DoD CIO, but there was something I mentioned that working with private industry on more offensive cyber opportunities and getting those out of typical like the NSA's, DARPA's, et cetera, right, who are typically doing that offensive game, and working with industry a little bit more on that. What that looks like, I'm not really sure, but you can see the augmentation, right, this kind of, I'm a team of one. Well now, right, as I'm kind of adding these agents on, I'm getting information, I'm sending them out, enrich this for me, enrich this for me, enrich this for me, to where I've got a fine tooth. I know exactly, okay, this threat actor associated with North Korea, this is what they typically do. This is what they target. This is where their expertise is. Okay, well, am I on that list? Do I have a problem? And then how have they done it previously? And then get the agent to provide me guidance on how to fix the hole, right? And so, I mean, it's agents all the way down, right? Yes, sir.
So how would something like this scale if you're scanning like thousands of machines versus like enterprise vulnerability management?
So it's not going to replace enterprise vulnerability management. Now, can it take action and do some things that is output from vulnerability management? Absolutely. And help shore up maybe some of that gap between, okay, well, this is telling me I have SQL injection, but I've got a novice individual that doesn't know how to fix that from a web application front-end perspective, right? But it can provide some of that guidance. It's not going to supplant any industry tool in that way, no. But the outputs for those to take action on them or make them actionable in a very corporate way, make it a data-driven insight, right? It can definitely do that. Yeah. Yes, sir. Yeah. Well, it's been an absolute pleasure. I appreciate everybody's time, and thank you for coming to my workshop. Yeah.